some technical issues. I will start with introducing myself. Hi guys, thank you for joining us today. It's like pretty big honor for me because since it's my debut in this kind of event. I'm Carolina. I'm based in Wrocław. I work as BI developer and also as a product owner. I have almost 6 years of professional experience. First, I was working for Santander Bank. Now, for more than 2 years, I work for Lingaro. And through my whole career, I work in both backend and front end of BI, so data preparation, building ETLs, obviously building dashboards. And lately, also, I'm enjoying a lot creating dashboard mockups in Figma. Outside of work, I love observing and photographing storms, watching all kind of sports, and also I'm a big Marvel fan. And now I think I can share my screen finally with you guys. And yeah, let's do this. Okay, so moving to our today's topic, since we are still a bit in Valentine's Day mode, how to go on a date with Python instead of prep and still end up in Tableau server. So first, why we even want to do that? From my perspective, if you are like me, I like to write the code, not necessarily directly in Tableau. And also the other thing is that using Python might be basically blocked for you in your company to the Tableau server function. And what we are gonna do today, imagine you want to prepare a dashboard that will show, for example, sentiment analysis of the review. So basically, we'll tell you if the sentiment was positive, negative, or neutral. So first, we need to prepare the data using Python, obviously. Then we need to run some analytics and then use the results of this analytics as a data source for the dashboard. So we need to publish it on Tableau server. And how you can do that? So Tableau is providing the REST API that gives you a lot of possibilities, that kind of the access to the backend of Tableau server, where you can query and check what kind of data sources they are there, project workbooks, subscriptions, schedules, data flows, sites, user, and many more other things. And based on this REST API, there are basically like few really good like Python libraries. First one is the Tableau server client, which is built by Tableau and it's official. The other one, Tableau API Lib, it's based on this official one, but it's more useful, more user-friendly, have more functions. And the other one is Tableau Hyper IO, which basically allows you to convert the data frames to the Hyper files. Okay, so let's go on this date and jump to the code part. First, we need to load the libraries, so the three that I mentioned. Additionally, pandas, transformers, and torque. It's just because of the sake of the analysis that we will be providing. First, we need to load the data. For today's, I have a simple data source with few reviews around romantic movies. So this is how it's structured. Then we need to do some data transformation. So we will start with just lowering the uppercases in the review. Then we need to run the sentiment analysis. First, we need to load the pre-trained model called BERT. And it's like, you can use it for the multi-languages, not just English ones. So let's load the model. The other function is to just run the analysis and generate the score of the sentiment. And we need, yeah, there we go. first function sentiment score, and the other function is to assign the sentiment score to the class of the sentiment. Now we can run the sentiment score and sentiment class. Bang, we have the sentiment of the review. Now the fun part. First, we need to connect to Tableau server. One important information to be able to do any operation with the API, you need to have a minimum Explorer can publish access. That's the first thing. The second thing, you need to have like a Tableau personal token. In order to do that, you need to go to your account, my account setting, and then create the token. Okay, let's do. No worries, I will delete those later. And one important information here: if you're creating the token, you can copy it once. You are not able to see it twice. So you need to remember to save it somewhere. Okay, so since we have the token, now we need to put them as variable. So first the token name, then the token itself. Save it. Now we need to configure the connection to the Tableau server. So first you need to put the Tableau server address. That's the first thing. Then API version. I will show you in a bit how to check your API version of your Tableau server. Then personal access token name, which is the one that we put it here. Same for the token itself. And then site name, which is like the site name that you see somewhere here if you have multiple sites. And the other one is the site URL, so it's basically this part after site in the address. Let's load it. Most of the servers are updated to at least probably 2021, 2022 version. And if you put 3.90 API version, then it will work, but also it will show you if you have the higher version. So first, Tableau connection. This is like the connection where we are putting Tableau config, and we are running this. The second part of this code is just to checking if the connection was okay. So you see your Tableau server is REST API version 3.22. So we will do this, we assign, and this is the information that we know that we are connected and everything is working fine. We can do some operation on the Tableau server. But what if we do, let's say this, just to show you when you know you are not connected. You will get this error. So if you get this, there's something wrong. Okay, back to the proper one. Okay, and since we said that we want to have the extract as a data source published on Tableau server for the dashboard, first we need to convert our data source, our data frame to Hyper. And we need to keep it somewhere temporary. So we are converting this, but this will be saved somewhere where you provide the path to the file. So you putting the name of the data frame, and then the address, and also the file name and Hyper extension. Okay. Now it was saved in our local computer in my case. Now we need to upload the Hyper Tableau server. In order to do that, first we need to figure out where we want to put it and what is the ID of the directory where we want to put it. Because like the API is operating on IDs, unfortunately, maybe fortunately, not on the names. So if we go here, let's say we have the TUC Poland directory and we want to put the data source in the data sources directory. So first, we need to find the ID of the parent, which is tag Poland. So we will query and list out all projects that we have on the Tableau server. This is like top 4, just to show you how does the data looks. And then we need to create a function that first will get the ID of the parent name, in our case, tag Poland. Then based on this ID of the parent name, you will also need the information about the data sources directory. So first checking parent name, then checking the directories that are under parent directory, and then finally getting the ID of the target directory and return the ID of this directory. So in our case, we want to get final ID of the data sources, and the ID looks like this. Then we need to publish basically the data source. And we again need to configure some connection to this. So first we use the function publish data source that is predefined and created already. But the parameters we need to define. First, we need the file path of the hyperfile. So basically this one, where we save our hyperfile. Then we need to put the target name of the data source that will be on Tableau server. Then the directory ID of the target place where we want to put the data source. And then optionally, we can put the description of the data source. And going to this, we are putting file path, publish data source function, data source name, data source directory ID, which we got it here, and optional description. And if we do this, okay, let's publish the new one. We know that this should be displayed like this. So if we go to the Tableau server, data sources, yes, we have 6, 7 p.m. Okay, this is the data source that we wanted to have. So now we have the data sources and can create the dashboard. So that's the main part of my presentation, but also I want to put to your attention another cool use case. So imagine you have the CSV files that your business putting from time to time somewhere, and on your database there is a trigger that is loading this file, and you have the data flow that he is using those data sources based on the CSV file. So you don't want to have, I don't know, scheduled run flow or go to the Tableau server every time something is updated and run it manually. So what you can do, you can, after in the script that you are loading the data sources CSV files, you can put at the end kind of run the flow after data load. So you can, again, query and see the list of the data flows that are on the server. In our case, we just have one for this presentation. Then we defining the function that run the flow. So we finding, again, flow ID. And then using the predefined function, we are running the flow. So let's do this. And if we run the flow, we think. And it's supposed to run. Obviously, something is not working at every presentation. But yeah, you need to believe me that it will run in the end if you configure everything properly. And yeah, and good practice after all the data transformation is also to close the connection. I put a lot of other transformation that you can do, which is like list out the list of the project, also send them save them to the Excel in the end. List of the workbooks, kind of details of also the workbooks, list of the views in the specific workbooks, data sources. You can even download the workbooks, list out users, data sources, a lot of things that you can do. And the functions, they are like split it between add something to the Tableau server, create, delete, download, get, publish, remove, query, and update. So if I put it in, yeah, that's a lot of function that you can, a lot of operation that you can do. So yeah, I'm pretty sure this workbook will be shared with you guys after this session. And yeah, that's that. Thank you for listening. Thank you, Pavel and Gauss, for trusting me. Yeah, hope you like it. Yeah, thank you.
Thank you, Carolina, for your speech. Guys, do we have any questions to Carolina? You can use the chat like Marcin, you can uh, or you can use your microphone. So Marcin asked about does a hyperfile have to be saved locally before uploading to server, or is it possible to send data to server without saving?
In my case, in my use case, I haven't found a solution to save like the data frame directly to the server. So it has to be saved somewhere, locally or SharePoint, OneDrive, but it's supposed to be saved somewhere to be able to transfer it to the Tableau server.
Okay. And another question is from the Pavel. Does it also work with Tableau Cloud?
Yeah, it doesn't matter. It's just like Tableau server, Tableau cloud. It always will be working. Yeah, even we have the Tableau cloud here, and in my cases at work we have the Tableau server, so it works. It works in both versions.
Great. Awesome. I don't see new questions. Oh, we've
Yeah,
got something from Igor. What kind of permissions do you need for it? Can a non-admin do that?
yeah. You have to have Explorer can publish at least, so be able to basically do the modification on the server or cloud. Yeah, and if you have any questions or maybe need some guidance on this topic, you can find me on LinkedIn. I'm happy to talk to you guys. So feel free to do that in the future.
Awesome. Thank you, Karina. If we don't have any new questions, I think we can go next with our survey, which I mentioned before. So, Agatha, if you could please share
Yeah,
the.
I will do this. I am prepared, so I can do
Okay,
this.
yeah, sure.
Yeah, is this one, I believe. I hope you can see it. So this is
Yes,
the
yes.
QR code and URL if you like to use it. I also pinned to the top link that Pavel placed in our chat. So you should have a quick access to it. And we encourage you to take a minute and try to answer 5 quite simple questions. And this is mainly the icebreaker because, as Pavel mentioned, we are operating after a longer break. So first of all, we want everyone to feel welcome and to get to know each other a little bit better. And yeah, so take a minute. Mm, I don't know if I should still show it or maybe one more minute so everyone can answer it.
There are no bad answers there, so
Yeah, yeah, of course.
keep calm.
And this is anonymous, so we cannot track you. So there are really no bad answers. Um, Okay, so maybe while you are filling your survey, I'll start. So the first question was, what was or how did your data story begin? And for me, it was visualizing survey data because I am a sociologist and I started doing market research. And then I was doing a lot of presentations. So that was my beginning. How about you, Pavel? And I can show the answers.
Yeah, so I started with the Alteryx and Tableau, basically doing some reporting stuff. So probably it's the similar path. Yeah, so I received some data and I need to create some really useful dashboard in Tableau, of course, with option download to Excel.
Of course, I mean everything has to be downloaded to Excel eventually. But I think you are not alone because for many of us, the data story begin with Tableau or some other program like Alteryx. What else? R. I am wondering who mentioned R. Is it a R Studio or was it more of a data analysis? And did you have a chance to use some, applications with that? If you like, you can, put more details in comments. I'm really curious who mentioned R. Mm. Okay, how about the second question? What are our unique skills? So for me, it's mostly design. As my husband like to, joke, I am basically taking chart, rotating it 90 degrees and change some colors. So this is basically my job. So I can see that for many of you is similar. Uh, I don't know. How about you, Carolina? I think you have some different unique skills.
Yeah, I mean, from my perspective, the most important and the best one is to super quickly find dependencies and relationship between the data. It's
Mm-hmm.
like no matter how many tables I have, it's always easy to navigate. But yeah, data visualization is also like kind of my go-to.
So you are a human computer. You can just take a look on the table and find some correlation, right?
Yeah, I mean at this point probably yes.
So you don't need any data visualization. You can just read numbers.
Yeah, I mean data visualization is important for the business, not for us, right?
I would disagree because I am a visual person and yeah, but this is definitely some unique skill
Yeah.
because for me I need to have visuals to
Mm.
to see some trends. But I see also people mention Tableau prep, nice, and advanced analytics, data modeling. So we have more of a analytic people on a call, which is not surprising considering the subject of the presentation. So the next question is, what would you like to learn this year? And mm, maybe I will show results first. Mm, I see some data engineering. So yeah, definitely you are in the right place. I mentioned server administration because for me, what you, Carolina, presented was pure magic. So this is definitely some area for me to unlock. How about you, Igor?
Right, I can see a lot of people mentioning Python. I'm here with
Mhm.
Python testing. It's
Okay.
seriously one of the hardest things for me personally.
Mm-hmm.
I'm definitely struggling on this side of data engineering still, and I know that many people working for many years with Python do struggle with it. Other thing that I'm planning to learn this year is more of storytelling. I find
Okay.
it very interesting how you can say with less more, how users are actually more engaged and more willing to consume our content, which is often more important than actually giving them more and more of it, right? That's what I tried to train for the last Iron Viz, and it was really interesting.
Yeah.
How is your storytelling, guys?
For sure, better than server administration. So I don't know how about the rest.
Yeah, I still need to learn about that too. So
I guess it's never-ending story, right? We just keep on learning because, yeah, I mean, it
technical
changes.
part is kind of easy.
Yeah, exactly.
I absolutely agree. Storytelling is way easier.
For you,
Yes, definitely.
then
That's the
then
funny part.
administration. Yeah.
In administration, definitely. Storytelling is pure fun.
Yeah. Yeah, I mean, and in consulting, I guess you need to, learn bullshitsu and have to, have a blackbird. So it's somehow connected to storytelling as well. Maybe it's a little bit easier for us. Okay, so what is your source of inspiration? For me, is definitely, maybe I will show answer so you can get inspired. A lot of people mentioned LinkedIn, and I was wondering if it's some specific person you are following or just some hashtag in general. So maybe some, tips how to stay in touch in the best content. You can paste it in the chat. Uh, some of you mentioned Udemy, so probably some specific courses, communities. Any specific community or Tableau public or Tableau user group or some others? I'm wondering if the person that mentioned this could be more specific.
I was responsible for this answer, and I think that I like general the BI communities like Alteryx or Tableau community, where we can find some fixes.
Mhm.
Probably all the questions from whole world, they are there. So
Mhm.
yeah, it's amazing from my perspective.
Okay. And I see some of you mentioned nature and books, and this is actually now when I'm thinking about that, it's quite similar for me because I am a keen traveler and I like to travel a lot and combine it with my other passion for data visualization, and therefore I like to visit as many museums and galleries as I can, and experience and see how different people visualize the information. And this is also a great source of inspiration. Mm, so yeah, I'm glad that I'm not the only one. Mm, and our last question is about our favorite chart. And we already had some heated discussion about that. So some of you mentioned, of course, pie chart and donut chart. Um, what is the pizza chart? Is it some kind of pie chart with that show the progress of how much pizza was consumed? Is that the chart? I don't know who mentioned this. Agata, do you have your favorite one?
Well, I would say it depends on day, mood,
Of
and
course.
everything. But if I am to choose the one I'm enjoying every time, and it's really easy to pass it to my clients, then I would say Comet chart. It's really easy
Okay.
to understand, it's really easy to digest, and it's really fun to write this complicated calculation to color it. And the calculation
And
makes
what
it
is
fun as
the
well.
the comment chart?
Comet
Is
chart.
it
It's one
yeah?
that looks like small comments running one and the other way, and showing what's the difference in what's the progress of your measure between 2 points of time.
Okay. I get it. Because I also chosen the safe answer. I mentioned well selected one. So as always, it depends on the data and the context. And Yeah, I guess that's it. I hope you enjoyed this part, and if you have any comments, you can put them in the chat, and um, I think we can move to our next section. And Igor, the stage is yours.
Let me just share my screen with you. How can I do that? Share this. Sorry, I have multiple screens trying to figure it out. This one, now you'll see my notes. And here we are. Alrighty, so hi everybody, and thank you so much for having me here. Really excited. My name is Igor Galowski. I'm a founder of a business intelligence consultancy, DataDune, and I'm a visual analyst and a data engineer like many of you. Couple of tools that we are working with. You probably know all of them. I mean, you're mentioning that you even started with Alteryx, your whole journey, Paul. So yeah, nothing new here. A couple of our clients. And what are we going to learn today? So I'll be discussing today with you best practice around data engineering for Tableau and how do we get from queries like this, mind that here I'm only timing the query itself of 160 seconds. How do we get to 10 seconds or even to 5.5 seconds? And this is simply only for data engineering. On visual performance, it's a separate topic, right? So however, arguably data engineering, I would say it's more important often, since you know when your dashboard has 100 sheets and you know when those are just misperforming, you know when you overdid LODs and all the other stuff, but in the end, when you're querying something for 160 seconds, you cannot really do anything, right? It's always the same story, garbage in, garbage out. You get a poor connection, you get too much data, you get it wrongly. Well, in the end, we are being blamed, right? Because it is our report is misbehaving. So having two aspects of our work, the social and technical skills, I'll briefly discuss the soft part, the communication skills of our work. So let's discuss, would you prefer to receive this one as request, or would you prefer to receive this one, which actually means exactly the same? Now, a lot of my work is around communicating with the stakeholders and managing them, and I bet for you it's the same. You have the easy stakeholders and the work goes very easily. You have those that you're just reading third time the message and don't really know what do they want from you. Like, this becomes really complicated. It doesn't really have to be. And as an example, I'll bring here the Pioneer plague. It was sent to space in 72, 73. And it's a brilliant example of how we as humanity, we thought about communicating something to somebody in a context. Everything depends on a context. Everything depends on who are we communicating those things to. And now, why am I discussing this? Because when we are speaking about data engineering, often we are not doing the work. I mean, I'm assuming the majority of people on this call are analysts. We might be doing a lot of data engineering, like with the presentation before. Some of us are experts in API and Python. I don't know if this presentation really aiming into you, but majority of us don't do both heavy lifting. We don't do platforming and data engineering and Tableau at the same time. We try to focus. That's why we are here on TUG. So when you're seeing something like this, I need user data accessible in Tableau. Now, this is a very short request that you might send to somebody. And as a response, you will get, okay, here we have all the data accessible through a Bastion and DynamoDB. Now, you might be thinking, this is not really what I want. I don't want all of the data, and definitely not through a Bastion. And Jesus Christ, like, there are so many things wrong with this. Yeah. And then we start the whole communication issue. Now, if you would rather spend some time and write, what do you really want? I want only GitHub user data. I want it in our Snowflake server. I want it aggregated to a specific monthly basis, and I will be using it on a daily use as planned. Now, what this will tell to the data engineer, that we need only GitHub users, that we need it in our instance and we want the aggregation, and perhaps in the future they also want it daily. Now, they will be maybe preparing it for you, both the aggregate and not aggregated version, so in the future there will be no problems. Now, things like this can be very quickly solved at the very beginning. Now, you can also add extras if you know about them, right? So would you like to say that implement indexes on the following columns? You can think in front. If you know that you will have 2, 3, 5 terabytes of data, they will be misbehaving. If you expect that there will be some problems, you might be thinking about the performance ahead of time. So when you get the dev time with a team or with a developer, they will be doing all these things from the beginning, which will be easier. So enough about communication. Let's speak about the fun stuff, the geeky things. So I'll be discussing with you today data modeling, aggregations, cleaning, validation, indexing, partitioning platforms, and a couple of extras. Like to all the concepts I will discuss, there's much more to it. On the data engineering side, this is by far not a 25-minute course on how to become a data engineer. This is more about the knowledge that we should all have to know how to communicate with the previous step being data cleaning. So let's start with data modeling. Now, in data modeling, I think the most important and the basic concept is speaking about data normalization. And that's something that I notice a lot of Tableau developers are a bit skeptical about, because this is the kind of thing of, this is annoying, I have to figure out how to join all of this stuff and this will be slow. Well, in reality, there are two sides to it. If you don't have to do it, then you are saying, oh, I have all of those columns, this is working so slow, who put 150 columns in this one table? Well, depending on a project, it depends, right? But knowing how it works definitely helps, because we shouldn't be annoyed in any of the situations. We should treat it as, this is what it is. Do I need something else? Do I understand why do I need it? So for those of you not knowing what is data normalization, you have two options here. You either have the denormalized table on the right, where you have everything together, think about 100 columns, or you have the perfectly denormalized table on the left. One of those, you've probably seen it. Majority of it are only IDs. And then you have everything in between. You have many levels of data normalization. Some of them you will have some IDs when you're connecting to other tables, but you also have some data that might be to some extent repeatable. Now, what does it change for Tableau? Well, not the speed, not really, not directly at least. Because we are facing here two issues, right? On the left side, we have the size of data. So instead of having one table with tons of rows and tons of columns, now we have multiple tables. Okay, so we're using less data. That's fantastic. That means we'll be loading faster. But then you're coming to a problem of, okay, I don't have enough of data. I actually need more. I need to union this stuff right now. I have to join it. I will do it in Tableau. Well, that probably is even worse than having this stuff denormalized from the beginning, which is why a lot of data engineers and a lot of projects are coming to a conclusion, you know what, just drop everything in one, it will be okay. They will figure it out. They will do an extract. So we start from normalize and reduce the size, and with all of the benefits of it. Then you join in Tableau for the minimum that we need. You measure the performance and move the joins back to the database. And only then we materialize either in a materialized view or in a table in the database, which will allow for minimal size and no join in Tableau. This is what works the best on projects if we have time, obviously, step by step. Again, just explode everything or majority of those things. It will also help other developers when they're working on other things. So you are not monopolizing the table because this is exactly what you need, right? Exactly what I need is not exactly what you need. And there's usually more than us alone in the whole business intelligence department, right? So just go to the minimum. And if you need it, then in the presentation layer, you can always ask data engineer, look, can you make me another one in front of this? I mean, these days, storage is really not expensive. Unless you're working with really a ton of data. And then those concepts, you have to take it again to another level and think about pros and cons of all of this. But majority of time, it is speed that people are complaining about, not are we spending too much money on storage? How much are we spending? A couple of $100. Well, whatever, right? This is, for majority of companies, it's a second of their existence. So let's have a walk through an example. You get the following normalized table, all in one, orders, customers, invoices. And then we decide to, you know what, let's maybe normalize it. So we're having everything separate. You have customers, you connect them to invoices, but also to the delivery address, all of this stuff, pretty basic. Now, in Tableau, you need many of them, right? So you're deciding that customers and orders, they must be together because you're trying to make a report about customer orders. This is what you will be doing. Then you come into conclusion, look, the performance is not really working too well. Devs, 4 joins, can you make it for me? Sure. Presentation layer, customer orders. You're having your materialized view. You're telling them how often are you refreshing it in Tableau, or the data is being refreshed somewhere. They're refreshing the materialized view every week. Problem solved. The performance should be better. You're just loading less data at this point, right? That's what you really did. And it also has other benefits. So we can speak here about the data anomalies. For example, the insert anomaly. So think about this small table. What do you do if you want to add another employee, but you don't know the manager? You still have to add it, right? If everything is together glued, you cannot do that. What about if you'll be having an update anomaly? Actually, I should have clicked again. What if on the left side, Jack will change the department and you didn't change the manager? Now, those things, if you have very normalized data, are simpler to do. What if you, this is the third one, the delete anomaly. What if you delete Monica because she quits? Now you don't have the finance department at all. It just disappears because you had everything in one place. Well, you know how it goes in Tableau. Now you have to do scaffolding, and now you have to maintain it, and probably you'll be doing it in Excel, and then you decide to change the so many things are happening later on down the road, not immediately. This is just collecting the tech debt, seriously. So what will this allow us in Tableau? You will avoid scaffolding if a department disappears. You will have no error like an employee manager because something got wrongly updated. You will have more consistency and no duplicated data. And as a small bonus, literally small, you have multiple normalization forms. So again, from the world of everything is in one, all the data we possess, until everything is separate and I'm not able to read anything because of just a bunch of IDs. There are plenty of gray space in the middle where companies are choosing, usually stopping on the third level of normalization. Well, this is good enough. We can still read this stuff, it's still humanly readable, and we're not overspending time on the whole modeling. I'll be speeding up a bit, otherwise we'll be sitting here until the morning. Data modeling, other to consider. It becomes a bit problematic, okay? Now we exploded a lot of things and we have hundreds of tables. So when we do that, we should request data engineers for a lot of documentation and data lineage. Data lineage is not only for some folks. It's not only for some dev sitting in a basement. It's for everybody, also for business users. If you're looking for good ways to do it and you don't use, for example, Snowflake or dbt, which have it by default, you can write yourself a bit of Python code and you can implement lineage in GitHub using Mermaid. GitHub is actually for free, visualizing it for you. Then you have links for all your stakeholders and anybody can know where the data is coming from, where is it flowing. You as a Tableau developer, you know how to join those things, you know how to speak with people. Product owners know how to do those things. They will not be digging in code and trying to figure out in SQL and Python where things are coming from. It's literally for everybody. And second thing to consider is indexing, but about this a bit later. So why is it important to a Tableau dev like me? Well, you could say that this and the following knowledge is hardly your job, right? But it's neither easy nor quick to make such designs, and knowing what you want and communicating with the data engineers will probably make it happen, at least it's more likely. And also, more often than not, many data engineers will say, this is not my work, okay? I'm here only for Python and R and whatnot. This is not my job. Well, in this point, it is their job, first of all. Don't let them say it's not. And second of all, if they will be arguing with you, you might have to step up and do some of those things. So knowing about them, knowing what to expect from those people, knowing that this is possible, knowing that we shouldn't be blamed for all of the Tableau problems. For some, probably we should. I'm looking at your 100 sheets, dashboards that I've been making before, but some of them not. If you're looking at the analytics and you are having a very long query time, maybe it's the data, maybe it's the platform, maybe it's, well, the whole architecture of slowing down with lags. There is some problem somewhere there, and we should be aware of it. And also, if you understand those things, and for example, like when you're editing relations, the cardinality, the referential integrity, if you understand how the model works, how the data engineering part of it works, then you can easier work with this. You don't have to each time Google what was cardinality and how do I use to speed up things. Worst case scenario, if you use those settings wrong, you're actually slowing things down. Many to many is the maximum thing that you can do, and it's not great if this is not your cardinality. But if you will select something like one-to-one, but it's actually not one-to-one, you might be having incorrect data coming back, incorrect results, and you will not even know about it. And once you will notice it, you'll be struggling to figure out where is it. Because will you think first, oh yeah, that was the cardinality. I screwed out the cardinality. That's why the sum is wrong. It's not the first thing where you will check, right? So definitely worth knowing those things. Now, next topic, indexing and partitioning. Let's speed up again a bit. So what's indexing? It's an internal way, internal structure, think about ordering. Now, let's make a quick exercise to demonstrate. Look at the left table. What's the name of employee ID 7? Look on the right table. What's the name of employee ID 6? It's harder to look for it. It's just ordering. Look at the left. What's Vivek's ID? Looks on the right. What is Anna's ID? This is basically what you're asking to do if you're not doing indexing. If you're not doing proper indexing and it's by default and happens, for example, on the left, but you're actually always looking by employee ID, you are asking the server to do harder job. It's pretty easy for a server to work on 8 rows. It's not that easy to work on 8 million or 8 billion rows. So the indexing becomes more and more important, more you're scaling your data. Now, index it all. He said that indexing is good. Let's just index it all. It's not so simple, unfortunately. We cannot index everything. Indexes require additional storage space, and they will slow down the writing to DB, because indexing what is happening in the background is actually replicating some of the data. So when you're writing to it, now you have to write to many places. A lot of places have to be updated. Additionally, on some databases like MySQL or Postgres, you still have to do manual stuff. And I'll be showing this to you in a second, what's the difference between Postgres and Snowflake. Lastly, composite indexes. So you have a way to index on multiple columns. So you could say, do it both the ID and employee. This can be efficient, but you can also do it wrongly, and you should read about it before. And if you see multiple of them in the code, let's say you find it in SQL, make sure this is what you really need. Because if you are predominantly doing on ID and only secondary on employee, and you will do in the opposite order, then actually you're hurting yourself. If you are not using the other column almost at all, the first one, you're also slowing it down. It has to be finely tuned. Now, there is a balance there, right? Don't do it on 15. Try to find, I would say, single most important one. Communicate it to the data engineer if you have performance issues. For example, you're working on a lot of data and you are doing it by ID, but by default, somebody did it by time. Now, this is slowing you down. If you're not using it and you know that this is predominantly table built for your reports, perhaps you can suggest it. Look, I've seen in SQL, we are making indexing that way. I think let's try the other way, at least for a week. I will test the performance. It's a very quick fix. Now, what about partitioning? We'll discuss two related concepts. We have partitioning and data tiering. First, those concepts, as many other, change its way and availability based on the databases. So this is just a general overview of it. We have product and sales, and you being asked to create reports separately. You have one report for consulting, one report for subscriptions. Now, why not to split them? As simple as that. You want to use less data. You don't want to use Tableau to filter this data because Tableau is still receiving everything, right? Like literally, if you look at the query, it says select everything from, okay, here I have 150 million. And then Tableau is, okay, I will filter it out. Or in some circumstances, because it really depends, it will be sent like this. But even if you're sending it to the SQL using Tableau, to the server, then still this operation has to be done, right? So still we're talking about this indexing. Okay, how is it being split? Now we're having the clause of either group by or where. It doesn't have to be that way, right? You can literally have two separate tables, and this is what partitioning is about. If you need it together majority of the time, and you're seeing yourself doing all the time unions, you can ask for a third table. Again, all depends on the size of your data. This is usually handled more neatly. This is just an example. Okay, so now there will be a tiny bit of SQL. How this works in Postgres. You are creating a table, you have 3 different columns, and you're saying partition by a specific column. Now, this is the manual part. You're creating a table, measurement 2024, partition of measurement. Then you're creating another one. Now, what if you want to partition monthly? There's somebody literally sitting there and coding this stuff manually and maintaining it. Now, if you compare it to newer solutions like Snowflake, I don't work for Snowflake, I just like them, all right? And probably many of you do because Snowflake just works very well with Tableau. Creating a table, you're clustering it by. That's all. The rest is happening magically in the background. Yes, you can still fine tune it. Okay, you still have micro partitions. And I know there's plenty of things I'm not discussing, but by default, there's zero maintenance on it. And this is great. Let's go back to our previous slide. So we partitioned it by product, but we almost always use it together. So let's speak about data tiering. I think I skipped some point here. I think I'm missing a slide. Forgive me for that. Data tiering. Think about this partitioning, but for data that you are no longer using or using less often. So again, we're speaking about having a lot of data. You are not doing it for your 100 rows data. You are having data that you were calling hot. Okay, this is data that is for the last 31 days for daily reporting. We need it for their C-level. It has to work really fast. Fantastic. We can create literally a table like this, only with data for the last 31 days. Not a view. We're not requiring it. We are counting that at night, this will be partitioned on its own and moved around. Then you have the warm one. Usually we're talking here about monthly reporting last 12 months. Then you have the cold one, last 5 years, full data, annual reportings. Then you're having archiving, 5 years and everything older. And then maybe at 10 years, you're just purging it because you don't need this data anymore. Now you can still access all this data if you want by just unioning them, but by default, you're only accessing last 31 days. In the hot one, everything is working so much faster in comparison to keeping God knows for what maximum granularity data for the last 15 years, like you've probably seen a lot. And then what are you really doing? You're creating an extract in Tableau server because data engineers don't want to do it for you. It's not a good solution, right? So what to communicate to the data engineers? Common joins. The most important dashboard uses orders and returns together on order ID. So that's indexing and that's the new tables. Then you have common queries, ordering by order date or grouping by customer ID partitioning. And use cases, for example, we report separately daily and monthly. That's tiering. 23 minutes. Guys, if you want to kick me out, tell me. I still have 10 slides. I will run through them. Optimize abbreviation. Quickly through this. What would work faster? 15 million rows or 7 rows? aggregate it if you can in the SQL Server, not on your level, because Tableau is doing this work, right? I mean, Tableau is good at a lot of things, and it did kind of become like, this jack of all trades, but in the end of the day, it is a predominantly visualization tool. If you look at the Tableau Server components, the part that makes the visualization is actually the one that's supposed to take a lot of space. And more often than not, we are adding and adding components that are making more extracts and more data transformation. It's a waste of money because this is not what Tableau is really efficient at. So this is how a lot of people are saying export and then Tableau. All right. What are the signs of this? Just clean it in Tableau. Okay, we don't have time. Or let's write a custom connector for this. We totally need it. Tableau will handle it. Or can we export data from Tableau? Because you cleaned it so nicely. You know this is not good. Make it like it's supposed to be. That's as simple as it is. And I know that on many different projects, when working in startups, when the project has a very tight deadline, we have to do those things. There's no time to push back to find a whole project management. God knows how many levels are in the corporation that you're currently working for. It takes time. But sooner or later, we should go back to it, or we should at least communicate what is the best practice. This is what we do. We are business intelligence experts, right? It's not just to be pushed around and make another dashboard. It's about showing this is not the right way. If you are working on a multi-million-dollar project, would you just start making 50 different calculations in Tableau? No, you would want to do it the right way. So almost at the end, we have platforms. Now, the difference between platforms and what you should know, what data engineers and the platform engineers are doing to you, is mostly about all LTP and OLAP. So, for example, you have MySQL and you have BigQuery. Which one do you want to use for your reporting? You should know that you have the online transaction processing. This is, think about transactions. You have many of them, like you going to a shop like to Carrefour or somewhere, and a lot of shopping is happening all the time. You have millions of transactions. This is where it's going, to MySQL. Or you have online analytical processing on the right side. This is what we are using. Now, if they're giving you millions of rows in MySQL, that's probably shit. You want to tell them, look, this has to be moved in a nice way, BigQuery to Redshift to Snowflake, whatever. Use the OLAP when you can. This is one of the reasons why your performance might not be that great. Like I promised, was quickly. Extra, pivot. As mentioned before, Tableau, I think I mentioned before, Tableau prefers long rather than wide. So instead of having 100 different columns, try to pivot them. Perhaps many of them have a commonality like, let's say, category. Pivot them, again, not in Tableau, but on the server. Tableau will prefer this. And yeah, we understand how less data is more for us. So make sure that this all contains the right amount that you really need. And lastly, documentation, like I mentioned before, it's for all of us. It's really important. I know it's boring. Nobody wants to do it. But if a bus hit me today, my client knows how to continue. And this is important to me. Don't forget to document your own. And monitor the performance. Don't wait for your clients, for your stakeholders to come to you and say, you know what, my team wasn't really using those reports for a while. We should know that, right? We should spend a bit of time. We should have this in mind, that the most important is for the stakeholders to make decisions based on our data. It's better to have an ugly, small pie chart and that's all, and just monitor it. If people are making decisions based on it, this is great, rather than they have the most beautiful magical dashboards that nobody is using because they are either slow or there are other problems with it that we just didn't take time to take care of. I think we covered all of this. I'll skip the slide and thank you so much for listening. Any questions?
Thank you, Igor. Yes, if you quickly answer on our questions. So, Pavel asking you about, would you say what's the role of a thumb in finding the right column to index? The one we are joining on or filtering by?
The right rule to find the indexing. Again, I can see the question. Would you share the rule of thumb of finding the right column to index when we are joining or filtering by? Let me think. The rule of thumb. I don't think there's a rule of thumb. I would say that for indexing, I would go with the one that we are sorting on in our Tableau. And by joining, if you have extensive joins, it will be also very important because this is how Tableau will be looking for the right match. So it really, again, depends on the platform. Let's say on Snowflake part, if you're currently correctly indexing it, then you have also concept of micro partitioning. So you have big clusters and within that you have small clusters. Now, if you make two joins between them, Snowflake will stop at ID 10 if you index it by ID and will not look through the remaining of them. So if join is your primary goal here, if you're making heavy one, do it that way. However, if you may be using small joins, if you're trying to just do some scaffolding, then perhaps filtering will be more important for you. But remember that to make it efficient and you are aiming into indexing for joining, you have to do both tables that way. Otherwise, you will still be struggling. I hope that answered the question. There's no really rule of thumb here. It really depends on your use case. If you have access to SQL, it takes you not much time and resources to re-index it. Again, depending on the size. Sorry, I feel like I'm failing on this question. It's a tough question.
Yeah, we understood. Uh, Question from Veronica: are there good, bad data types for creating indexes?
Yes. So you should always be aiming into indexing or something on something that is quite unique. You don't want to index on Tableau category when you have only 3 of them because it doesn't really make sense. Like it's still very random inside. Use data type that is as short as possible and as unique as possible. You can even index an ID or I'm often indexing it on a timestamp because timestamp is something I'm very often building my dashboards on. I'm using it in filters and yeah, I think rule of thumb, I would go usually for filtering because that's what I'm doing majority of time. My complex joins are just being sent back to the server.
Okay, sure.
Okay.
Thanks for your answer. I think that we ran out of the time. So, guys, especially Karolina and Igor, thank you for your inputs today. Thanks all for joining. Next session will be provided by end of May. Uh, and I think that we can close today. Of course, you can reach out us using the LinkedIn or our speakers. Thank you very much and have a lovely night.
Thank you so much.
Thank you.